Hi, this is Mr. Word. I'm going to do a short video on a common mistake I'm running into in folks' work on quadratics 13, and probably it'll show up in some of the others. Here's the deal. When you have a square root that can't be reduced and just a whole number or an integer or just any other number that's not inside the square root, treat them as unlike terms. I'm going to walk through this problem to illustrate what I'm talking about. So I've got the square root, I've got x squared plus 8x minus 2 equals 3, and I'm going to complete the square. So I'm going to add 2 to both sides, so that becomes plus 2, and it becomes 5, okay? And then I'm going to find half of 8 and square it and add that to both sides. So plus 8 over 2 squared and plus 8 over 2 squared. Now 8 over 2 is of course 4, and 4 squared is 16, so we'll just call it that there. And I'm going to go down here and turn that back and turn that into a 4 and simplify 5 plus 16. 5 plus 16 is 21. Now I'm going to factor both, well, I'll factor the left side. So the left side becomes x plus 4 squared equals 21. Then I need to get the square root of both sides. So the square root of x plus 4 squared equals the square root of 21, which will be a plus and minus square root and is not reducible. You do not have any perfect squares contained in there. So I get x plus 4 equals the square root of 21. Now, and it also I get x plus 4 equals negative the square root of 21. So first, make sure you know that. So there's a plus and a minus. Then the next step is to subtract 4 from both sides. So I do minus 4 here, and I do minus 4 here. And I'm going to do the same thing with the other version. So the other version will be minus 4 minus the square root of 21. Now, what I'm seeing some people do is take this minus 4 and put it inside the square root. But this, let's see what this is all by itself. That's minus 4, or that's just minus 4. Okay, I'll get rid of the x so you can see it. There, it's just minus 4. But what is the square root of 21? Well, you get that. All right, well, what happens if we put minus 4 plus the square root? We get a totally different number. Okay, this is different from just adding that. Okay, it's also going to be different from subtracting. As we put these next to each other. So these are totally different meanings. So this 4 is already neat and tidy. You don't want to put it back into a square root. Putting it back into a square root would mean you'd have to turn it into a 16, and you can't even jam that together as well. So you just want to leave them separate. This is a number that doesn't need to be in the square root, and this is a number that has to stay in the square root. Keep them separate. So this one is going to be negative 4 plus the square root of 21, and I'm going to just delete the wrong answer, okay, and negative 4 minus the square root of 21. So those are my two solutions. So treat square roots and numbers that are not irreducible square roots as unlike terms, just like you treat 3x and 5 as completely separate things that can't be mashed together. So you can't say 3x plus 5 equals 8x because we don't know what x is, and 5 is a standalone number, and 3 is with a variable. You also cannot do that with an irreducible square root and a number that is not an irreducible square root. Treat them as separate. It's a sum or a difference, and that is where I will stop.